We're going to replace this 100 amp Bryant Load Center with a new GE Load Center. This Bryant is a 100 amp 20 circuit going to a 100 amp GE 32 circuit. So I'm really just increasing the amount of spots that I can fit breakers in. And this panel right here does not have a grounding bar. One could be installed, it was a little difficult to find one, and I already removed a bunch of wires, as you can see in here, so it is kind of freed up a bit. It was much more cluttered, and really there was no room for expansion. It was completely filled. I even had circuits when I moved into this house that were sharing the same breaker. So for example, my living room and my dining room both had 15 amp, or I should say 14 gauge wire coming in, and they were wire nutted together and then connected to a single 15 amp breaker. So obviously not up to code. A lot of this stuff is pretty old and crusty, and I have some very old BX cable. To my right, you can see a bunch of brand new Romex NMB cable. Most of it right here you can see is yellow, which is your 12.2 gauge. And I also have one white so far. I'm going to have a second one and a few others once I go through updating the rest of the cables in the house. But a lot of this stuff is brand new or will be replacing old BX cable. And then the one orange 10-2 wire you see there is for the central air condenser, which goes outside, and that goes on a 30 amp breaker. All the yellow cable, which is your 12.2, that's going to go on a 20 amp breaker, and the white wire, which is your 14.2, is going to go on a 15 amp breaker. So I won't exceed a 30 amp breaker in this box. Everything in my house has been updated to gas, meaning gas stove, gas direct vent, tankless water heater, gas furnace, gas dryer. So I don't have a huge demand for electricity in this house, so I do not really need to upgrade to a 200 amp main. So instead of upgrading my service, which costs roughly $2,000 from a quote I got, I can just upgrade my existing panel to get additional room in it. So I have room for expansion. You can see in comparison that the load center is substantially larger, a lot more room to kind of neaten up and tidy your cables around. This will give me plenty of room for expansion, and because I don't need 200 amps, this is pretty much as big as I can get. First, we're actually going to test to make sure our tester works. So for example, I can see both my wires coming in from the meter box right out here are live and hot. I'm going to unplug that meter. I'm going to come in. Obviously, if everything turns off, that's one indication that there's no power coming in from this box. But you always want to test this and verify if any other wires are coming through this main conduit, or really any of these wires, because you never know what happened, especially back in 1941 when this house was built. Anything got jimmy rigged or anyone was trying to steal power and bypass that meter. Just go over everything, make sure everything's completely dead. You do not want to start taking this all apart and find out you have a live wire coming in this box, because you won't have a good day. So once that's dead or no longer live, I can disconnect these two hots, disconnect this neutral, disconnect everything else, disconnect the ground that's going to my water main. I do not have in this particular setup, I do not have a grounding rod set up. After I get everything off, I'm going to take down this wood. They are too small of a surface area to accommodate the larger size of this box. You can see the difference in size. So I actually need to take that down and put up my new backer board that I have already pre-cut and painted. The reason why I'm taking this down is because this is 3/4, this new board's 3/4, and my water main over here is basically flush with this now. If I add another layer of plywood on top, it's going to bring it up too far, and then I'll have to come up with another mounting solution. So rather than doing that, I'm just going to take down these, expose the two 2x4s that are mounted to the wall, the concrete, which I have behind me in the basement, fasten the new plywood to this. Then I'm going to take the new GE load center, align it with this metal conduit coming in from the meter. I got the meter unplugged. There's a new digital meter they put in about a year ago. So Make sure once unplugged, test everything. All the lights and everything went out in my house. I got my 3 wires coming in right here. Make sure, in your case, if it's not labeled, this is the neutral. These are your 2 lines in, your phase, 2 phases. You want to make sure you label these so when you reconnect it, you make sure you have them in the right spot. You want to put your neutral on one of your hots, for example. So I have to label this with white tape and label these so that when I connect it to the new GE load center, I don't reverse or do anything. This is my ground right here, which runs down here, and it connects to my water main. Pretty much everything else is just some residual wiring I need to remove. Take all the BX out. It is going to get replaced by a new Romex cable. Another issue I had was I have my bathroom downstairs, my bathroom upstairs, my cellar lights, my kitchen lights, hallway and the 2nd floor, the hallway stairwell going from the 1st floor to 2nd floor lighting, the lighting in 2 or 3 of the bedrooms are all in this 115 amp circuit. So even when I take this off and put it back on, I have a mission to go through and start breaking that apart. So far what I've done is I ran a brand new Romex cables to all the lighting in the basement, brand new switch. So everything is now on a 14-2 Romex cable. It'll be connected to a 15 amp circuit. So that'll get that off of here. So little by little I'm going to start pulling additional things off of this circuit right here to reduce the load on it. Hopefully just eliminate and update everything with new Romex cable. Everything in here is dead. So we are good to go. Flick this off. These are obviously already dead. They're no longer alive, I should say. Some people just go in, they start cutting all these. I have already labeled everything. So for example, freezer, 20 amp, bed clock, 20 amp, sink plug, kitchen sink plug, 20 amp, deck lights plus outlets outside, 20 amp, living room, dining room, my 50 amp, I labeled it to split it, and I got some more down here, disconnecting all the neutrals, and since I have BX armor-clad cable, many of them, if not all, almost all of them, I think, except for one in here. None of them have a ground. The grounds are the actual shielding themselves. So when they're used with a metal connector, the box which is grounded, it grounds these shields, and those armor shield cables are fastened with a metal connector to the actual metal boxes. Alright, so we got everything removed except this one last wire. Got my neutral and 2 hots from the meter box right here. Got this kind of pushed out of the way. And I got last BX or armor-clad cable right here. Gonna twist off this connection nut, slide it down, pop this through. Try and guide these through without chafing or scraping the shielding of these wires. There's the grounding wire, metal conduit, rigid conduit down to the water main. And disconnect this. Not even that tight. And That'll do it. I just freed my box. Alright, now I gotta hammer off the nut on this conduit coming in from the main, or from the meter. Alright, now we're going to unscrew the box from the board. Be careful of your wires. Alright, we have the box removed. We got all the wires, except for that one right there hanging out, removed that were coming through the bottom, through these holes. Got everything removed from up there. Now it's time to start taking off these boards. Alright, so I removed the first board, which is right here, but I'll give you guys a little demo of what I'm doing. Alright, time to mount the piece of plywood on the wall. The 3/4 inch plywood is now hung. I used 2.5 inch self-tapping stainless steel screws, as you can see right there and right there. I used 5 running the right and left hand side vertically, which go into the 2x4s that are mounted to the cement walls. There's my water main. You can see it transitions to PEX, and I'll have it mounted right in the edge of the board right there, which is why it jets out a bit right there. We are going to use the knockout in the center. So right here. Gonna grip it with my pliers. This is for the main coming in. I got the conduit through the knockout. Put 1 screw in here with a washer. And right now I got a level up here. I got this level. Box is mounted. Now we're going to put a 1.25 inch plastic insulating bushing around these wires. So now we're going to install the neutral wire, which I have marked as white. Whoever wired up the previous box made these a little long, especially for my liking. If you see it, put this in, you can see how much it protrudes out. So I got some cable cutters, channel locks right here. And then I'm going to use a 3/16 Allen wrench. There's the bonding screw that bonds, a grounding screw that bonds the case the neutral bar. And this is the bonding bar that goes between the two neutral buses. So this will be my ground bar, this will be my neutral bar. I need to bring a ground wire down here. And I'm going to put it through that knockout. I'm going to carry that through down here, and then tie it into my water main on this. We're going to work with some EMT tubing for creating a ground conduit going from the bottom of the box to the water main. I'm going to be using this EMT fitting that will screw into the box into one of the 1/2 inch knockouts. This will basically go from the box, go back slightly, and then go down, which will basically make it flush with the wall. Instead, if you had the pipe going directly out, it would be a little bit away from the wall all the way down. I have my EMT tubing on the ground, it's 1/2 inch, and then I got EMT 1/2 inch pipe bender. I'm going to line the arrow with this line, and now I'm going to bend this on a 90-degree angle. Do that, step on this, and just pull the lever gently. Okay. So now I got my bend. Now it's 7 inches on the pipe bend that I just made. I have another mark. Right here, so it's 7 inches from here to here. I'm going to put this on that line. Once you have your EMT tube bent, draw a mark wherever you need it cut. And in my case, I'm using a small, just what I had in hand, a small copper pipe cutter. You could use a hacksaw or reciprocating saw or a sawzall. However, if you do, your cuts are not going to be clean, and you will need to deburr them. I recommend deburring it even with a pipe cutter, just to make sure you don't snag a cable. But you can see I have a line up my cutter wheel. I'm just going to rotate that around a couple times. And there you go. How to easily cut EMT pipe and cleanly. Now I'm going to use a Klein power reamer. This will be used to deburr the in and exterior lips of both ends of the EMT conduit. All you do is you press fit it in there. So that end is now deburred. Alright, now you got two deburred ends. This Klein tool will actually do 1/2 inch, 3/4, and 1 inch. Now I'm going to mount this new conduit in one of these knockouts. Now you're going to run your ground cable through the EMT tubing or conduit. I'm just reusing the same cable that was used as a ground before. I think it was 6 gauge. Yep. Then you're going to take your fitting, slide it over the end. Tighten that loosely, slide it through the hole. And then tighten on your connector, or your nut, I should say. And pull the wire you need through the conduit. I'm going to be putting it in this screw right here. I'm going to put a new end on there. Then tighten down your screw. Then down here, I'm going to slide on your Romex connector or coupling. Slide the cable through. Next we have our clamp on the water pipe right here. And we're going to fit keep it loose for now. I'm going to fit this cable in here. So first I'm just going to cut it a little large. Then I'm going to strip it. You're going to tighten this down. The screw will screw down and clamp the copper cable. Make sure you make this nice and tight. So you have a good solid ground. And then you want to screw it nice and snug on the copper piping. Now that we have our ground installed and connected to the water main, two-phase hots coming in, our neutral on the right, everything's connected. We're ready to start taking some knockouts. So I've already pressed a 1/2 inch knockout here. You're going to take your non-metallic clamp. They also sell plastic ones, but I prefer these. They're a little more secure. And they don't damage the outside shielding if you accidentally pull on it. And they're easier to take the cable back out when you need to. So this is for my air conditioner, the condenser specifically. And this requires a 30 amp breaker. Everything else is going to be on either a 20